All right, thank you so much for joining us today. We started with coordinate geometry and we talked about distance between 2 points, gradient, slope, equation of a line, internal division, external division, and many, right? So right now we want to look at circles, and basically we are going to need some formulas also from what we learned from coordinate geometry. So as I said, I'll give a useful information after the video, right? So I just want to just start so that we can just start. All right, so let's start with circles, right? So let me assume that I have this something like this here. Yeah, I have something like this here. So and then I have a circle, big one. So this is my circle, which is very nice. And then let's assume that I have a center somewhere here. And then I have this line here. This line here is my radius. So I'm going to assume that I have a point, let's say point P, which is X and Y. And then I have my center, which is A and B, right? So one thing that we can notice from here is from the center to the circumference is the radius, right? So now from this center to this P, we can call it a distance, right? So we can talk about distance CP, right? So from here to here is a distance. As I said, we will need some of them from coordinate geometry. And we know that this distance here is the same as the radius. So we can say that this is equal to radius. So now let's use the idea of um, formula for finding the distance between 2 points, which is, let me say, C and P, and then we used to work out this. All right, so let's see what we are going to get from here. So distance between 2 points, remember the formula, right? Remember that if I have distance between 2 points, then the distance is equal to y minus, okay, let me start with x2 minus x1 squared plus y2 minus y1 squared, right? So that's what we are getting. So basically, this is what you are going to get for the distance. So let's use this to be my, let's say, x1, y1, and this one to be my x2, y2. So I'm going to have the distance to be root of x minus a squared plus y minus b squared, which is equal to r. So that is what I'm going to get. And then what I'm going to do is I'm going to square both sides, right? That's what I'm going to do. So let's do that. I'm going to square both sides. So square root of x minus a squared plus y minus b squared, all squared is equal to r squared. And this square will cancel this root. So we are going to have x minus a squared plus y minus b squared, which is equal to r squared. This one should be 2. So you see that we form a nice equation here where we know that a and b from here is the center, right? And then r here is the radius. So this is a big formula that we need to have in mind, right? It's a big one that we need to also add it to what we just want to do. So as I said, MERB series is out there. We have the formulas there. Try and get some for yourself. All right, so I call this the basic formula for circle, right? So the basic formula for circle is given by, so I'm going to write this one. So it's given by x minus a squared plus y minus b squared is equal to r squared. Good, so that's the basic. Now, what is the basic formula for a circle through the origin? So when you say through the origin, we are trying to say that through the origin is like the center is 0, 0. So here we are looking at center 0, 0. So we know that the center is A and B. So this is going to give us something like A minus x minus 0 squared plus y minus 0 squared, which is equal to r squared. So the formula is going to be x squared plus y squared is equal to r squared. Good. So this is the the equation of the equation of the circle through the center, right? So basically that's what we need to get from here. So what is important here is we just need to learn this and then have this one to here, right? Now let's look at further expansion on this. So we just learned that the basic formula is this, right? But we are going to form another equation of the line in different form, right? So let's try and do that. Let's try and expand this. So how can we do this? This is the same as x minus a plus y minus b, which is equal to r squared, right? So let's try and expand that. So x times x times a times x, and then a times a. So this is going to give us x squared minus ax plus minus another ax plus x squared, right? So let me shift this guy here. Then plus same thing with the y. This is going to give us y squared minus by again, right? Plus b squared is equal to r squared. Good. So that is what we are going to get at the end of the day. Let's try and simplify. So we are going to have this one to be x squared plus y squared. So we are grouping terms with the squares with y and x, and then the one with just y, right? So look at this one. We can see that we can factor s out, right? So when I do that, I'm going to have something like, or even I can combine it. Okay, let me just do the combination before we go there. So this is x squared minus 2ax plus a squared plus y squared minus 2by plus b squared is equal to r squared, right? So let me just combine this one and let's see what we are going to get. So we are trying to bring out something which is going to be so nice, right? So what can we do here? I'm going to send all the constants, I mean the one without y and x, to the right side. So when I do that, I'm going to have x squared plus y squared. So I just have x squared plus y squared minus 2ax minus 2by. So I have this one here, this one here, this one here, this one here. So I'm going to send a squared and b squared to the right. So I'm going to have this to be, let me say, or even let me just maintain them here. So plus a squared plus b squared minus r squared is equal to 0. So let me just move all of them to the left side rather, right? So what we are going to do here is we want to make sure that this is positive, right? So what I'm going to do is, remember when we started this, we said the center is A and B. So now we are going to change the center here. What I'm going to do is very simple here. I'm going to let Jane to be equal to minus A and F to be equal to minus B. So remember, A and B are the centers. So this here implies that A is equal to minus Jane. And then B here is also implies that we have minus F. So one thing that we can notice from here is, if AB is the center from the basic formula that we learned from here, right? AB to be the center. Then from this expansion that we are doing, the center is the same as minus Jane minus F, because A is equal to minus Jane and B is equal to minus F. So we are getting this. So it means that anytime we are using this equation here, remember when you find it, you need to negate them. So when you find Jane, you need to negate them. I'll do example for you to understand. So now this is our center now. So let me just pick it and just put it up here. And then shift this guy also to the left or right side here. And let's continue. So now we are going to have x squared plus y squared plus 2 Jane x plus 2fy plus, so now we know that minus a is equal to Jane. So that's what I have done, the replace, right? I just did the replacement. Minus a is equal to Jane. So given us this, and minus b is equal to f. So giving us this. Now what I'm going to do is I'm going to make sure that I'm going to name um, this one here to be C, right? So I'm going to say that um, a squared plus b squared minus r squared is equal to c, like a constant. So that here I can have it plus c is equal to 0. So this is another equation that we are going to use them a lot. I mean, a lot, a lot. We are going to use this equation a lot. The one with the blue, we are going to use it a lot. So pay attention to that. So this is equation of the circle. Now, this helps us that anytime we have this equation, or when we have equation in this form, and we want the center, we know that the center is minus j minus f, right? I will just write them again, but I just wanted to put them there for us to see. Then what will be the radius here? So here, let's look at the radius. So since I have minus r here, I'll move it this way, and then I move the c also this way. So I'm going to have r squared to be equal to a squared plus b squared minus c. But we know that a is equal to minus j and b is equal to minus f. So let's do substitution. We are going to have minus j squared plus minus f squared minus c. But because of squared, this now turns to j squared plus f squared minus c. So what will be r? R should be equal to square root of j squared plus f squared minus c. Good. So we've done a lot here, but I'll just, that's why I brought this here. I'll just write them for you. So now the question is, the center of the circle is given by, so now the center of this circle now is given by this. The center is minus j minus f. So have it in mind. Anytime you have the equation in this form, this is my center. So when I find j and I find f, I need to negate it, right? Good. What is the radius? The radius is what we've gotten here. So let me just put it here nicely for you. So r is equal to square root of j squared plus f squared minus c. So this is also the radius that we've gotten now. So center radius. Now what is the general equation of the circle is given by? So the general equation of the circle is the one with the blue. So this is the general one. So we have x squared plus y squared plus 2j x plus 2fy plus c is equal to 0. So we are learning some things here. So we have this, we have that, and we have this. Now the last question is, so we want to look at the general equation of a circle through the origin. So when it is through the origin, what happens? Basically, when it's through the origin, we are going to have this one to be, I think it should be in the form, let me say, so through the origin should have something like x squared plus y squared plus 2j plus 2fy without the c, which is equal to 0. So that will be just through the origin, right? So that is what you are going to get here. So don't forget center, radius, good, and then the general equation. And then this basically you don't need to even have it in mind, because basically if it is 0, we can just get it from there. So now we know the basic equation for circle when it is 0, and then we know the general equation, the radius and the center here. Very, very important. Very, very important. All right, let's go on. Like this video, we are trying to get all the formulas as we did for coordinate geometry. So let's look at this one. Equation of a circle on a given diameter. So it's kind of, if we are just from the high school, we are thinking of circle theorem, right? So if we are thinking of circle theorem, and then I just have my circle here, then when we talk about diameter, it means that it passes through the center, right? Then we have a diameter. So let me just have something like this. Very nice. So I have my center here. So this is the diameter, right? The red one here, I call it diameter because it passes through the center. But we want to form the equation of the circle on a given diameter. So what we can do is I can extend this to this point, and then I extend this to also this point, this to this point. And then I'm going to call this point, let's say P, which is X and Y. And then let me assume that my other coordinate here is A, but my A, let me assume that my A is X1, Y1, and my other point here is X2, Y2. X2, Y2. Right. Remember that anytime we have a diameter, when this meets at this, it forms angle of 90. So what do you see? Let me just turn the graph so that you will see something that I'm seeing, right? So let me try and see if I can turn the sketch. Good. Oh, that is so nice. Okay. It's kind of the way you are not seeing it well, but I think it's okay. Like you can see it. So you can see that this line here, that is line AP. When I finish, I'll turn it back for you to see. Line AP here is perpendicular to line PB, right? This one, they are perpendicular. It means that the slope of this is negative reciprocal of slope of this. Or in other words, the slope of this times the slope of this is equal to -1. When two lines meet at 90, then we know that they are slope. When you multiply them, you should get -1. That's what we are going to use here. When I finish, I will show you the other way too that you can do. So it means that now if we want to find the slope, so let's try and find the slope of line AP, right? Slope of line AP, and then we also find slope of line PB, right? PB. So let me make this one PA, right? Good. So basically that's what we want to do. So now that we are done with this circle here, let me just try and minimize this small so that I can get some space to write. Good. So now with the slope of this, look at what we are going to get. Now we know that if the slope of this is m1 and slope of this is m2, then if I have m1 times m2, I should get -1, right? So let's try and find the slope of PA and then slope of PB, right? So let's do that. So the slope is, we know that slope is equal to change in y over change in x. So this is what we are going to use. So let me assume that this is my x2, y2, and this is my x1, y1. So I'm going to have something like this. Basically, I'm going to have something like this. My slope for m1, so let me just form m1. m1 will be y minus y1 divided by x minus x1. That will be the slope for m1. Remember, m1 is for PA. So y minus y1 and then x minus x1. Then what will be my slope for m2? m2 is for this and that. So this is going to be y minus x2 divided by x minus x2. This one should be y2. So we said now when I multiply m1 to m2, I should get a -1. So I'm going to have y minus y1 divided by x minus x1 times y minus y2 divided by x minus x2, and this should be equal to -1. Good. This is interesting. We can do something here. This is multiplication, so we can multiply this and this and that. So this is basically going to give us y minus y1, y minus y2 divided by x minus x1, x minus x2. is equal to minus 1. This is divided by 1, so this will multiply this and this will multiply that. So finally, we are going to have something nice, which you don't need to memorize, but yeah, if you want to memorize, it's okay. But I think if we're able to set up your equation like this, and you know that you need to find the gradient of this multiplied by gradient of this, and it's equal to minus 1, then you don't need to memorize this. So this is going to give us y minus y1 y minus y2 to be equal to minus x minus x1 and then x minus x2, right? So this is what you are going to get. Then if I try to move this one to the right side, then I'm going to have something which is very nice. X minus x1, x minus x2 plus y minus y1 and y minus y2 is equal to 0. So this is the equation of the circle on a given diameter. So let me just write it here boldly. I'll give you the alternative, so don't worry. So x minus x1, x minus x2 plus y minus y1, then y minus y2 is equal to 0. Right. But in the normal sense, what you just need to do, we will solve example, you understand it better. But that's what we are going to basically get from this. Let me see if I have the alternative here. Okay. So let me do the alternative here, down here, then we'll see how we can do it. Now, what we can do here is, now the idea is that we are finding equation of the circle, right? And equation of the circle, what do we need? We need center and we need radius. That is another way that we can do. So instead of forming this, do you know what I'm going to do? I'm just going to form my circle. So I'll draw it here. So I'm just trying to show you the other way. So I'm going to have my circle like this, right? And then with the diameter, which is from this side to this side, from this side to this side, and then my center here. Now remember, A is x1, y1, and B is x2, y2. If I don't want to form this and use the perpendicular aspect, then all I need is for me to form the equation of the circle. I know that equation of the circle is given by x minus a squared plus y minus b squared is equal to r squared. So I need just the center and radius. And I know that if I want to put my center here to be, say, let's say my center is AB, then remember, anytime you have a diameter, from the center to this side is the radius, and then this one too is the radius. So it means that at this point we have a midpoint. So for me to get my center, I need to find midpoint of A and B. It's nice, right? Yes, that is quite interesting. So for me to get my center, if the center is not given, yes, I need to find a midpoint. So my center AB is equal to midpoint of AB, which is going to give me the coordinate. So if these are values, you will see that it's going to give us a center, right? So now I assume that when I find a midpoint, I'll get A and B, which is the center. Now, another thing that I need is I need the radius. But I know that for me to get the radius is from the center to the side. But we have two ways of solving the center. Now we know that I can use center and B to find the radius, or A and C to find the radius, or I can use AB to also find the radius. So let's check. Radius is equal to distance between BC, which is also the same as distance between AC. So if I want to get the radius, I need to just find the center between B and C, or A and C. Or I can just use the diameter approach, right? We know that when I have two radius, is equal to what? Diameter, right? So radius is actually equal to 1/2 diameter, right? So A and B are diameter. So the radius is also the same as 1/2 times the distance of the diameter, right? So if I don't want to find for center and use the center and one of the point to find the radius, then I can just find the distance of AB and then take half of that, and that one is going to give me the radius. So basically, these are the two ways of solving equation of a circle on a given diameter. So either I choose this or I choose this approach to solve. Basically, that is what I need to do. But sometimes when it is an objectives, you will see that maybe the answer is going to be in the form of expansion. Then when you are here, then it means that what you need to do is after you found this, you need to expand it so that this will be the same as this one too as well. So basically, that's what you need to make sure that things are working well for you on this side. So just pay attention to that. Okay, let's look at this one. Now, this is saying that equation of the circle through 3 points. This is a lot of hard work with this one. If you want to do this, a lot of hard work, but I'll give you the tricks. Okay, so 3 point means that let's assume that I have 1 point here, I have another point here, I have another point here. This question did not say they are diameters, right? So it means that the way that we are going to do this is different from the way we were doing the other one, right? Good. So let me assume that this is my A, this is my B, and this is my C. So anytime they give you something like this, remember this AB is a chord. This is also a chord. This is also a chord, right? And we are trying to find the equation of the circle, right? So this is the chord, right? Because if it is not diameter, then it is what? A chord. So what we can see is this point here is intersecting the circle. This point here is intersecting the circle. This point here too also is what? Intersecting the circle. And we know that if we have a point or two lines which intersect, what we do? We solve them simultaneously. So what we are going to do here is anytime you have a question like this, remember the general formula for circle. The general formula for circle is x squared plus y squared plus 2 gen x plus 2fy plus c, which is equal to 0. So this is the general circle for finding a circle, right? So if this is the general circle, then what we are going to do here is we are going to make sure that we plug in the point for A. So let me just name this point. This is x1, y1. Let's assume that my B is x2, y2, and my C is x3, y3, right? Then what can I do? What I'm going to do is I'll plug in this point inside this equation. Then I have one equation. I plug this point inside this equation. I have another equation. I plug this point inside this equation. I have another equation. So I have three equations that I'm going to use to solve three unknowns: Gen, F, and C. So basically that's what we are going to do. So I just gave you the step with the explanation. The step is also here. So given for equation of a circle through 3 points, we can solve by following steps, right? So suppose that the equation of the circle is this, the one that I wrote here. So anytime you have this one, then you have point P1, P2, and P3. So let's assume that this is P1, this is P2, this is P3. Then what we are going to do is we are going to put them inside equation 1. So like this is what I mean. This is equation I, right? So we put P1, P2, P3 inside I, which is this equation, to obtain an equation in terms of Gen, F, and C. So like we are going to have three equations with three unknowns. And then we are going to solve these three equations for Gen, F, and C. And then after we are now done finding F, Gen, and C, then we write the equation of the circle by doing substitution for Gen, F, and C. So don't worry, we will take example in the next videos, and then we will better understand how we are going to solve them. Good. Let's look at this. I love this, question here. Whenever a question is saying that, check whether the point is inside, on, and outside the circle. So these are the steps that you need to do. First, find the radius and the center of the circle if not given. So if it is not given to you, find the center and find the radius, right? So basically they will give you a point. So let's assume that I give you 1 point, let's say a point of P and Y, and I give you equation of the circle, right? Let's say this is the equation of the circle: x squared plus y squared plus 2 gen x plus 2fy plus c is equal to 0, right? Then what I need from you is you are going to check if this point is inside, outside, or on. So the first thing I need to do is I need to find radius using the equation of the circle here. Then when I finish, I need to find the center using the equation of the circle here. When I finish, find the distance between the center of the circle and the given point. I think it's time for me to just sketch so that you better understand it. Good. So this is my circle. This is what I mean. And then they've given us the equation of the circle: x squared plus y squared plus 2 gen x plus 2fy plus c is equal to 0, right? And then I have a center here, and let's assume that we have a point. So they've given us a point, which is, let's say, let me make this one x1, y1. So this is the point, x1, y1. This is the point given to us. So what we want to do is we want to find out if this point is inside the circle, on the circle, or outside the circle. So what we just need to do is we can do this by comparing this to the radius, right? Because we know that this is the radius, and always the radius is on the from the center to the circumference. So if 1, so 1 is on, or let me say, let me do inside first. Inside. So inside is when, so let's assume that this is P, we have P and we have center, right? So remember, when we are done, we need to find the distance between the center and the given point. What is that? So let's find the distance. So let's assume that we find the distance of the center and then the P. So this is it, and then we have our radius. So what we are going to do is we are going to compare the distance between the center and the point, and then the radius. So the point P will be inside the circle when the distance of this is less than r. So if the distance is less than r, then it means that it's inside the circle, because we know that this should be this. So anytime you find the distance between this and it's less than, then we know that P is somewhere inside the circle, because we know that from the center to this point here is inside the circle, and then the distance between this and then the distance between this, you see that this is less than that. So that's what we mean by inside. Let's talk about 2. 2, we are going to talk about on. On is when CP, distance CP is the same as R. That is when I have my P somewhere on the circle here. So you will see that the distance between this and this is the same, because from C to P is the radius, and this is also the radius. So whenever this is the same as this, then we have this one to be the radius, and we are going to say that the point is on the circle. Last one is 3, right? 3, outside, outside, outside the circle. So outside the circle, you can clearly see that that is when the distance here is greater than r, right? So what can we see? We can see that that is when we have our point P somewhere outside. So you will see that the distance between P and C will be greater than the distance for the R. So that's what we have. So basically, that's what we are going to get for inside and outside. So these are the 3 steps that we need to go through. Find radius and center if not given. When you are done, put the radius somewhere. What you need to do is now pick the center that you found, and then find the distance between the center and then the given point. When you are done, compare the distance with the radius, and it's going to give you one of this. Is that right? Good. You see, math is fun. always there is a shortcut. So somebody is asking, what if it is objectives and I need to have a shortcut? Yes, I'll give you the shortcut. So another way that we can do is, you see, when I said they will give you this equation of the circle and then the point. So the equation of the circle is given and the point is given. So for me, I don't want to find the center, I don't want to find the radius, but I want to get it right. So how am I going to get it right? What I'm going to do is I'm going to plug this point inside this. When I plug this point inside this and it is less than 0, because here is 0, this thing is equal to 0, right? So when I plug this point inside this and I'm getting something negative, which is less than 0, then I'm saying that this is inside. Interesting, right? Then when I plug in this, so oops, this one's supposed to be y1. Yeah. Now let me use black for that. So this one's supposed to be y1. Then when I plug the same point inside the whole of this and I'm getting 0, then I'm saying that it is on because it will be equal to 0. Then when I plug in the point inside the whole of this and I'm getting something greater than 0, then I'm saying that it's outside. So you see that this is the short way. Instead of finding center, finding radius, and then using the center and the point to find the distance before you compare, I just plug in the point inside this and then check if it is less than 0, equal to 0, or greater than 0. And I know that if it is less than 0, inside, equal to 0, on, and when it's greater than 0, outside. So I'll take example in some of the videos where we are going to practice all the two ways so that you will choose the one that you want to choose. And then we are done with that. Okay, so let's look at this one. So I hope you are here with me. Still, we are working with the formulas, trying to understand the whole stuff before we take examples, right? So intersection of a circle and a line. Good, I love this. So we are talking about intersection of a circle, right? So let's assume that I have a nice circle here. Boom. Good. Now what I want to do is, now I have a line that I want to go with. So I just want to have a line. So there will be like, whenever we are talking about intersection of a circle and a line, it goes with inside, on, and outside, right? So I'm going to just do three things here that you are going to see. Let me just minimize my circle here. So let's see three things that I'm going to do here for you to see what I'm trying to do. So one, let me put here one. So now one here is when I have a circle and then I have this. Can you see this? So here I have two intersections, A and B, right? And let me assume that this is my center. So you will see that the distance, let me show you, the distance from the center to the circumference is always less than the distance here, right? So basically you will see that the distance here is the radius and here is the point. So you see that this one, whenever you have two intersections, we are talking about point, we are talking about the point inside the circle, right? So this is having two intersections, right? So two distinct points of intersection. Good. So anytime I have let me say a point inside the circle, I have 2 points of intersection. So for example, what we just did here. So as I was doing, if I have this and I have my radius and I have a point which is inside the circle, then when I draw a line which passes through the point, I have 2 points of intersection, right? But we are going to learn something unique also here. Look at something, what is happening here. This line here is 90. So you see the green there. Can you see it? Let me just zoom it for you to see. So you see there is 90 here. So I'll just put some B here. This one help us to, it's also another question that they can ask you. You know, if I want to find the distance between this line and this line, let's go back to coordinate geometry. we saw that whenever we have a line and another line and they form at 90. So I'm just taking what is here, the black line here and then the blue line. So we see that here is C and here is D and here is A and here is B. So anytime I have something like this, what comes in mind? Good, you had it right, perpendicular distance, right? So anytime I want to find this line here, which is blue, I need to use the idea of perpendicular distance. So let me just put something there for you to remember that perpendicular distance. The blue is perpendicular distance. We are learning a lot today. So that is what we are going to get from there. So you will see that we will solve example, and basically they can give you the center here, right? They give you the center, and then they give you the equation of this line. They want you to find the distance between C and D. Very simple to do that. That is all. Very simple. So that is when we have inside the circle. So this is inside. With inside, we have two distinct points of intersection, right? We have two distinct points of intersection. Let's look at two. Two, we are going to look at, let me see here. We are going to have something like um, um, on the circle. So on the circle is something like this. So I have the point here, right? So we get 1 point of intersection, right? So that's what we are going to have, 1 point of intersection, right? And this is when we are talking about on the circle, because you will see that this is on the circle. So if I have my center somewhere here, right? If I have my center somewhere here, this is my center, right? So this is going to be my radius, right? Because now if I want to find the distance between this, the same thing, I can use the perpendicular distance because this form angle of 90. So this one, I can also find radius using the perpendicular distance. So don't forget this red line here, which is the radius. If a center is given and this line is given, then we can use what is called perpendicular distance to solve that. So this is called my D. This will be the equation of the line. We will solve example and you see how we are going to do it. But basically what we need to know is if we want to solve a circle and then a line, then if we have something like this, then we are going to have 2 points, A and B. But this one is going to give us just 1 point, which is D right here, right? And then the last one will be, who can guess? You had it right. No point of intersection, right? So no point of intersection will be for who? Which one? Will be for outside the circle. Outside. So when the point is outside the circle, we don't have point of intersection. So you will see that, let me just draw this one very well. So I'm going to have something like this. Nice. So let me assume that this is my center here. So I'm going to have a line from that point to this point. So this point here, which is D, is greater than radius because from this is greater than radius. So basically we are talking about outside, and this one too is forming 90, and I can also use the idea of perpendicular to do that. So this one, no point of intersection. No point of intersection. We are learning a lot here. So we can see that basically it's the same as what we were doing here. C, if we are using the C and P. So here, if I'm using C and D, so you see that here C, distance CD is greater than R. Can you see that the distance from C to D, this distance is greater than the radius? When you look at this one, you will see that CD is the same as the radius, which talks about on the circle. And then here, my radius is the one with the red. So let me use red. My radius is the one with the red. So you see that distance CD is less than R, which talks about inside the circle. Inside the circle. So that is what we can do here. So another last thing that I'll leave with it, like last thing that I'm going to do here is, you see, whenever they give you this and this and you are solving, we are solving it simultaneously. So what you are going to do is you are going to sub this inside this, right? So basically that's what we are going to use to do that. We will solve example on that, and then I'll show you how you can use this to solve with the tangency and stuff. Right, good, good. Let's look at equation of the tangent line to a circle. So when you talk about tangent line is something like this, right? Tangent line actually touch the graph at one point. So on the circle, this something like this becomes tangent line. So this line here, we call it the tangent line. Good. And then outside the circle, this line here becomes the normal line. So I will just draw them here for you to see. So I have my nice circle here with my line, and this line here, let me just change it to red. This line here is the one that I call it tangent line, right? So let me change the line to red. So this line here is a tangent line because it touches the circle at one point. It touches the graph at one point. So what we are going to do is, we want to find the equation of the tangent line, right? So basically, we are going to have a point here, and we are going to have a center, right? A center also here. Remember, this is the radius. So for us to find the equation of tangent line, we know how to find equation of the tangent line. So equation of the tangent line is y minus y1, which is equal to x minus x1. Somebody is asking, but this is the equation of the line. Yes, equation of the line, because this is a line. But the only thing here, only different is now this line is touching something at one point. So we are calling it a tangent line instead of a line. So it's the same thing here. Is that right? But look at something here. Anytime you are forming equation of the tangent, there is something that you need to notice from here. You will see that we will know the equation of this line. So this is what we are looking for. So they will give us either the center and this point, or what we are going to give is they can give us a point and equation of the circle. Then we use the equation of the circle to find the center. When you find the center, what we need to do is, since we know this point, let me assume that this point is x1, y1. Then what we need to do is, since we have one point on this line, we just need the slope, right? So we can use C and D to find the slope. But when we use C and D to find the slope, we can see that this line here is perpendicular, right? This my green line here, which is the radius, is perpendicular to the tangent line. So it means that we need to pick negative reciprocal of that. So the equation of the tangent line is given by, so I'm going to write it right here, is given by y minus y1, which is equal to, so here if I'm finding the slope of CD, line CD, slope of line CD, and assume that I'm saying that it's equal to m, since the slope is perpendicular to this line, then my equation of the line is going to be minus 1 divided by m x minus x1. So this will be the equation of a tangent line to the circle. So pick the negative reciprocal of that, and then you are there. You are there. So that is what you are going to get. Because if we assume that the slope of this one is m1, then since they are perpendicular, m1 times m should be equal to minus 1. Then if I want to make m1 the subject, this one will be minus 1 over m, which is right here. Good, good. So this is the equation of the tangent, nice one. But don't forget, this is for a circle. So always pay attention to this, because when you get to the derivative and we are talking about curve, something will change between the tangent line and then the normal line. All right, let's look at normal. Equation of the normal line. We are almost done. We are almost done. I'll give you the information and then we just go. So equation of the normal line is basically something like this. So I have my normal line, good, and then I have my center. But don't forget, from this up to this is basically the red one is the radius, right? So the normal line is that, and basically we have another, yeah. So this is the normal line. The blue one is the normal line, right? So this is the normal line, which passes through the center. So what will be the equation of the normal line? The equation of the normal line is like the same equation of the line, but let's see something here. Now this point here is D, so let's assume that the same thing D here. So for us to find the equation of the normal line, we need one point on this line, which we have D. So what we need again is we need the slope, but we don't know the slope of this line, so we can use the center and D to find the slope. So as we said, if the slope of DC is equal to M, then the question is, what will be the equation of this line, this blue line, that I mean the normal line. Now remember, this red line is on the blue line, so they are moving along the same line. So we are saying that they are parallel to each other. And we said from coordinate geometry that when two lines are parallel to each other, they have the same slope. So it means that the equation of the line here is going to be y minus y1, which is equal to mx minus 1. Very good. So it means that the m here is just the slope of this. Or if I just want to put something here, I just put CD here, but does not mean. So what you need to know is with the normal line to a circle, the slope is the same thing. So we just have the equation of the line, the same thing again, given the point D. So here we assume that D is S1, Y1, the same thing to this one to X1, Y1. Good, good. So you see that it's just we are trying to reciprocate. So if we are using this line to be the normal line, then when we reciprocate this 90, then we have the normal, I mean the tangent line, which gives us the negative reciprocal of the slope of this one. Right. Good. Let's look at last one and then we are done with this video. Yeah, this is the last one. Give you the tips and go. So last one is like equation of the common chord. We are trying to talk about equation of the common chord. So what are we trying to say? So equation of a common chord is like I have one circle here, I have another circle here, and then we have the same chord. So from this point to this point, right? So the blue line is chord. So this two circles has common chord, right? So let me assume that this circle is, let's say, S1 and this circle is S2, as I've done it here. So circle 1, S1 is this, and circle S2 is also equal to this. Then we are saying that the equation of the common chord is basically we using X1 to be the same as X2. So we are assuming that if they are having the same chord, then the equation of the circle is the same. So what can we do here? What we are just going to do is we are just going to equate S1 to X2 with the equation of the common chord. So let's do that. We have X squared plus Y squared plus 2 gen X plus 2FY plus C1, which is equal to X squared plus Y squared plus 2 gen X. Let me move a shape, something like this. Then plus 2FY plus C2, right? So I mean, this is the same as that. Because this is equal to 0, this is also equal to 0. So what happens? X squared will cancel X squared, Y squared will cancel Y squared. It's kind of interesting and amazing, right? So that's basically what we are trying to get from here. Now, what can we do? Now I'm going to do something here so that we don't cancel everything out, right? So what I'm going to do is let me make this one, let's say since this one is going, let me make this one Gen 1 F1 and then Gen 2 F2, right? So that we don't cancel everything down. So this one will be 2, no, yeah, this one will be 1, this one will be 1, this one will be 2, this one will be 2, because we are going with x2 and y2. So the only terms that are not changing is x and y, right? So now when I move them, I'm going to have 2 gen 1 x minus 2 gen 2 x. So I move this to this side, becomes negative, plus 2f1y minus 2f2y plus x1 minus c1 minus c2, which is equal to 0. So I just move everything to the left. So here what I'm going to do is I can factor 2x out, then I'm going to have gen 1 minus gen 2 plus factor 2 gen out, and this one is going to be left with f1 minus f2 plus c1 minus c2, right? And basically if I try to assign some variables to this, you see that they are going to be so nice here. Basically I'm going to get something very nice. So let's assume that I assigned, let's say a, let me assign a to 2 gen 1 minus gen 2, and b to be to 2 f1 f2, and c to be equal to c1 minus c2. Then my equation is going to be x, or ax plus by plus c is equal to 0. So this becomes the equation of the chord. How did I do that? You see, I'm saying that a is equal to 2 gen 1 minus gen 2. So gen 1, gen 2 is here times the 2. So it will be left with just x here multiplying the a. Because if I pick this x out, 2 of this is now equal to the a here. So this one will be left with x and a, and 2 f1 f2, which is this and 2, it will be left with just the y and then the b. And then this is equal to c. So I have it here. So don't worry, some of them you don't need to just memorize the formulas here. What we just need to do is we need to remember that equation of the same chord is when we equate the two equations together and then we solve them. We have some like kind of tricks that combines everything. So basically when we are solving, we are going to combine the tricks, and then we put all of them together to solve examples, and then we'll see how we can go about it. So I said I'm going to give you information. So as I said in the previous video when I was ending coding geometry, we are starting circles, and basically circles also depend it depends on coordinate geometry, because you are going to use the formulas midpoint, distance, as you can see from what we were just doing. We talked about perpendicular distance, we talked about midpoint, we talk about a lot of them. We can even use internal division and external division, all of them here. So make sure you pay attention with the formulas. So as I said, grab your MERB series. We have compiled all the questions there. Try to work more examples. The examples that we are going to take, when you finish, you can just take them yourself and then be solving it yourself for you to understand it better, right? So basically, that's what you are going to do. So in the next video, what I'm going to do is we are going to solve more examples to make sure that you understand what you've done better. Don't forget to share the videos with your colleagues so that they too they can enjoy. See you in the next video.